Adding or subtracting rational expressions is a little bit trickier than multiplying or dividing rational expressions. With adding or subtracting rational expressions, we need to make sure that we have a common denominator before we add or subtract them, and then follow again the same operations that you would do with numerical fractions with your algebraic fractions. This segment focuses on adding and subtracting rational expressions with common denominators that are already there. A different segment later on will talk about how to add and subtract rational expressions that do not have a common denominator, how you need to find out what the lowest common denominator for those problems would be, and to build to get common denominators. But here, let's look at the type of problems where the common denominator already exists. So let's recall back to our numerical fractions. Recall that if we had something like 1/12 added to 5/12, first, we want to make sure we pay close attention to the operation that's between the fractions, because by now there's several different operations that you've been taught how to do, and you need to make sure that you look at what the operation is to decide what the next steps would be. So here I'm to add these two fractions. Once you're to add or subtract fractions, the next place your eyes should go would be directly down into the denominator of the fraction. To add or subtract fractions, you must have a common denominator. So if you do have the common denominator, like we have in this case, these denominators are both 12, then to carry out the addition, remember we add and or subtract, depending what you have in your problem, across the numerator, but you keep the common denominator. So here we would have 1 plus 5 all over, keep that denominator of 12. Well, 1 plus 5 is 6 over 12. And then only once you get to the point that you've gotten your arithmetic done in the numerator and you've kept the common denominator, at that point you look at how to simplify the final result. And here I have our common factor of 6 in the numerator and the denominator, my 6 in my numerator, and 12 factors as 2 times 6 in the denominator. We can remove our common factor pairs of 6, and that leaves me a 1 in the numerator and a 2 in the denominator. So the simplified answer to this numerical fractions problem is 1/2. Okay, so let's look at it with some different algebraic fractions. The first algebraic fraction I'd like to do is to look at x over 8 added to 3x over 8. So again, I look between and I see that the operation to do is addition. Once it's addition or subtraction between here, the next place my eyes need to go is to the denominators. My denominators are the same as each other. They're both 8. So since they're the same, to carry out the addition of these fractions, I can add together the numerators, take x plus my 3x, and keep my common denominator. Now, in the numerator, because I'm adding polynomials, I want to do the process that adding polynomials requires. If there's any parentheses up in the numerator, I would remove the parentheses and then combine like terms. But here I don't have any parentheses, but I do have like terms. 1x plus 3x is 4x. So I have 4x over 8. And then recall that when it's 4 right in front of the x, with the numerical coefficient of 4 in front of your x, that means the attachment is multiplication. So to see if I can simplify this, I also want to factor out the denominator. So this is 4 times x in the numerator. In the denominator, 8 is 2 times 4 is one of the factorizations I could use, where I see I have my common factor of 4 in the numerator and denominator. And my final simplified result for this example would be an answer of x over 2. Now the key thing to look for here is that you just had one term in the numerator and I just had my one term in the denominator. So I factored those and removed my common factors. Let's look at this final example for this segment. Here I have a fraction subtract another fraction. And when I'm adding or subtracting, the very first place my eye should go after noticing it's adding or subtracting is in the denominator. And you say, are these the same? Well, x plus 3 is the same as x plus 3. So I do already have common denominators here. Well, once I notice I have common denominators, I want to carry out the arithmetic across the numerator and keep the common denominator. So I have my fraction bar, I keep my common denominator of x plus 3, and I have my first fraction, which, remember at the beginning and end of the fraction bar is a grouping symbol. So I have x squared plus 10x, close that parentheses, but this time it's a minus in between, so I'll put my minus, and then I have a grouping symbol that starts and ends for the second fraction bar. So open parentheses, 4x minus 9, close the parentheses. Now because we want to subtract in the numerator, I need to remove my parentheses and collect like terms. This first set of parentheses, I don't have any exponents on it. I didn't have any minus sign in front of this fraction, nor in front of the overall parentheses. So this first set of parentheses are unneeded. I'm just going to write x squared plus 10x. The last set of parentheses, I don't have any exponent on it, but I have a subtraction that's in front of an expression with more than one term. So remember, think about that almost as if you're taking a -1 and multiplying it through to remove the parentheses. So -1 times 4x is a -4x, and -1 times a -9 is a +9. So you want to make sure that you're extra careful about distributing that negative through all the terms of the numerator that follows that minus sign in the problem. Okay, then I have my denominator of x plus 3. Now combine like terms up here. I have my x squared, there's no like terms with x squared in the numerator. A plus 10x minus a 4x, they combine as a plus 6x. And then I have plus my 9 at the end, and this is all over x plus 3. So at this point in time, we're like where we were here in our numerical setting. We have our combined, our numerator as much as we could with the like terms, and we have our common denominator. But remember, we still want to see if we can simplify this final expression. And when you have more than one term in the numerator or denominator, you see if you can simplify it by factoring the numerator, factoring the denominator, and removing any common factors. Well, for x squared plus 6x plus 9, this is written as overall additions right now, not multiplication. I need to factor that. There's no common factor all the way through. There are 3 terms. It's in descending order, and the leading coefficient is a 1. So if this factors, I would need to have it so that my factors of 9, the numbers that multiply together to make 9, would also be numbers that add together and get 6, the middle coefficient. Well, 3 and 3 will do that. 3 times 3 is 9, 3 plus 3 is 6. So this numerator factors as x plus 3, x plus 3. The denominator is x plus 3. And if that's the entire start to finish, I can grab that in parentheses for my entire denominator. Now looking between the numerator and denominator, I see that I have a common factor pair of x plus 3's. And in my simplified form, I have an extra factor of that x plus 3 in the numerator. So that is my simplified answer for this question. The answer to the subtraction question is x plus 3.